Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this fourth lecture of Module 12 on engineering geological aspects of geothermal energy, coal bed methane, gas hydrates, shale gas, carbon capture, usage and storage. In previous lectures we have elaborated about gas hydrate, and in this lectures we will discuss about CBM and shale gas. Friends, in these lectures we are going to elaborate about engineering geological facets of CBM and shale gas. Regarding this, we are going to cover about introduction, particularly starting from CBM, and then formation of CBM, then about the coal types, minerals and maturity, and cleat system, then occurrence of CBM, reservoir of CBM, and then extraction of shale gas, and about engineering geological view on mechanics of CBM, etc. Friends, as you know, the coal bed methane CBM is a form of natural gas, extracted from coal bed, therefore it is called as coal bed methane. And advances in our understanding of coal gas interaction have changed the manner in which we have treated coal bed methane. Earlier, the methane is a hazard for the miners and sometimes caused the health hazards and even fatality also. So, with advances in technology, we have started from our journey from mitigating its dangerous as a minor hazard to developing its potential as an unconventional gas resources. So, two times benefits we have taken from the extraction of CBM from coal bed, and the production of CBM date back to the early 1930s is reported. So, people have attempted this extraction of minor hazard CBM as a profitable, and the major reserves exist in many countries, and the more than 90% of estimated reserves are located in Canada, Russia, China, the United States, Australia and India and other countries. You can see the contribution of different Russia, China, USA and others. Vegetations and others grow along with the availability of water and some suitable condition. Then in view of times the vegetable matters falling on the ground and interact with the water and others in domain of time started degrading and deposited inside a geological strata or material or sediments. This formation of coal bed methane depends mainly on the coal types, minerals means minor constituents present, micro constituent, and about the maturity. You can see from the ground it is made up of shale, sandstone, and then lower side we are getting coal. As far as the coal type is concerned, based on the availability of carbon or concentration of carbon, we can able to divide without carbon, that is the ground, then peat, then lignite, then semi-bituminous, then bituminous, then anthracite. As far as we are moving from the ground without sea, in ideal condition, although there is some sea in soil and others, but as far as coal topic is concerned, therefore this context 0C, and when this we are entering in grade of pit, there is increment in C in comparison to the ground, then again further increment in C, then further increment in C, then further increment in C, and finally anthracite has rich carbon. The bituminous and anthracite, mainly bituminous coal, we are widely utilizing, and we have huge deposits of the coal in our Gondwana basin, particularly located in India. The bituminous coal is consisting of some micro constituents like fuginite, like reactive semi-fuginite, like inert micronite, and other type of minerals. These minerals indicates in support of organic theory of coal, and because this coal is made up of organic material, therefore the gases encased inside the coal bed and recovered from this coal bed is recognized as coal bed methane. You can see one view. There is a different type of discontinuity. One is a simply bedding planes, another is a joint, another is of some cracks or fractures, and some of specialized type of fractures present in coal geologically recognized as cleat system. As found in nature, coal is a typical dual porosity permeability system because it is containing cleats, it containing beddings, it containing joints, it containing fractures, it containing pores. Therefore, we can say that the clay is comprised of some coaly material as well as discontinuity like bedding, like joint, like crack, like cleat, like pores. Therefore, we can say that the coal is containing two types of porosity. One is a primary porosity, another is a secondary porosity, and secondary porosity is complicated in nature due to presence of different type of cleats, bedding, joints, fractures, cracks, etc. Therefore, we can say that the coal is a typical dual porosity permeability system and different from the conventional reservoir rocks. Why? Because containing the system containing porous matrix surrounded by fractures, and these natural fractures form a closely spaced orthogonal network called as cleat. And cleat can be divided into two types. One is a face cleat, these are the face cleat, and the connecting is a butt cleat. So the main set of fracture termed as face cleat, these are face cleats, and secondary type is recognized as a butt cleat, linking. Butt cleats are orthogonal to the face cleat and often terminated at them. Butt cleats are also roughly planar but are not as well as developed as the continuous as the face cleat. As far as occurrence of CBM is a concern, because the coal having dual porosity and permeability, and the pores as well as discontinuity responsible for availability of gas or oil or anything, particularly we are discussing CBM. Therefore, the CBM concentration, the coal bed have host in form of bedding, in form of joint, in form of cleat, or in form of pores developed within this coal bed or in matrix. Methane occurs in coal as adsorbed on surface of coal, stored as the free gas in cleat and open pores. So CBM present in two form. One is as adsorbed on surface, particularly matrix of coal, and second is in free state located in cleat, bedding and cracks, either in gaseous form, either mixed with water. So 95% CBM occurs in coal matrix within micropores as a result of adsorption on the surface, and about simply 5% CBM occurs in pre-state, in cleat system, in bedding and in joint. Gas held in coal by hydrostatic water pressure, you can see the adsorptions in micropore responsible for holding 95% of the CBM, either independently, either due to hydrostatic pressure engaged inside the pores, and this 90% concentration of the CBM in pores under hydrostatic pressure is the main source for CBM extraction. However, the 5% present in fracture, cracks, bedding, joints and cleat system in free state either are dissolved in water. Much of the measured bulk or seam permeability is due to cleat system, although the presence of larger scale discontinuities such as fracture, joints and faults can also make a significant contribution in improving the permeability of coal strata or enhancing the permeability of coal strata. The coal matrix is isolated by the fracture network and is the principal medium for storage of gas. As we have already discussed, 95%, some people suggested 98%. So it means close to or more than 95%, principally in adsorbed form and with low permeability in comparison to the bounding cleats. So the micropores are responsible to hold major fraction of coal bed methane. The remaining gas is stored in natural fractures, we have already discussed, in cleat either in free gas or dissolved in water, and the surface area of coal on which methane is adsorbed is very large, and for example 20 to 200 meter square per gram, and gas is stored at near liquid densities. The flow rate in general, the flow rate of a fluid like gas is directly proportional to the area of cross section and length of the area of cross section, length of the formation and about the hydraulic gradient. Hydraulic gradient is nothing, it is a ratio of the difference of piezometric head or the gas pressure difference, and L you know well is about length. If we are considering this double porosity, double permeability system, then K is intrinsic permeability and small k is a coefficient of permeability, delta P is a pressure difference and mu is a viscosity of fluid, viscosity of CBM. Then we can change the general principle which we are utilizing in case of water flow. Q is equal to V into A, and V can be converted in V is equal to Ki so replaced by Ki, and in this finally we are getting K A by mu into delta P by L, where H is the rho by the R plus the Zp, and rho is the gamma is the rho into G. This is the P, where gamma is specific weight of fluid, rho is the density of fluid, G is acceleration due to gravity, and Z is the height above the reference datum line. The coefficient of proportionality K is known as coefficient of permeability and is generally used to represent the permeability of ground. So in such case this K value is different. Friends, if we are going to see about reservoir concerned to the hydrocarbon reservoir conventional and this coal reservoir, then we can see here the conventional reservoir utilized for extraction of petroleum or natural gas, having porous rock strata overlain by non-porous rock strata, or here permeable rock strata or permeable zone overlain by impermeable seal or cap, and this base is also impermeable so that not allowing movement of the oil and gas toward the downside and not providing this to move upward to break the seal and others. Here the porous rock strata is considered as a reservoir which are going to encage all the water or gas in conventional reservoir. However, in case of coal reservoir, as we have already discussed, it has double or dual porosity and permeability concept due to presence of cleat, due to presence of pore, due to presence of joint, fractures, cracks, etc. Therefore, we can say that the conventional reservoir high effective porosity and low compressibility is due to presence of these pores. So compared to the conventional gas reservoir, coal reservoirs have low effective porosity and high compressibility. However, the conventional reservoirs has high effective porosity and low compressibility. Why here coal reservoir have more? Because due to presence of this, the coal reservoir have low effective porosity and high compressibility and are dominated by gas distortion, therefore not allowing further for the movement of other. The coal reservoir have low effective porosity and high compressibility. However, the traditional or conventional reservoir has high effective porosity and low compressibility due to this intact grains of sand. For example, you can take the sandstone overlain by shale. The CBM recovery activate a series of coal gas interaction during extraction. The reduction of gas pressure in first step increases effective stress. When this gas pressure due to release of CBM from this zone, the gas pressure is released, then there is enhanced effective stress. The enhanced effective stress is going to reduce the aperture of the fracture or cracks or cleats or discontinuity, and through this earlier it was like this, due to enhance effective fractures there is a decrease in aperture. Therefore, there is a reduction in permeability at initial step. Later on in second step, there is increased permeability due to dilation. So as the gas pressure reduces below the desorption point, the methane is released from the coal matrix to the fracture network and make the coal matrix shrinkage. Due to shrinkage in coal matrix, here shrinkage in coal matrix resulted increment in aperture as well as formation of more fracture. Therefore, increase in permeability. So initially decrease in permeability and then increase in permeability. Cyclic type, decrease and increase. As a direct consequence of this matrix shrinkage, the fractures may dilate and volume change and fracture permeability correspondingly increases and resulting ultimate increase in permeability. If we are going to see here permeability and methane gas release, so in initial stage, this closure of, this is the fracture aperture. So gradually you can see release of methane gas resulting decrease in aperture and here. After some release, the fracture aperture is close to 0 and are very less and resulting low permeability due to decrease in porosity, interconnected porosity. Later on, the release of methane from the coal matrix resulting formation of shrinkage induced formation of fractures and crack as well as widening of the additional existing fracture as well as additional fractures, cracks and others, resulting dilation and increase in permeability. So one side here decrease in permeability or porosity, another side increase in permeability, porosity. In long term, permeability is greater or less than the initial permeability depends on the net influence of the dual competing mechanism, and here the decrease in permeability is sharp. However, in shrinkage induced formation of fracture is gradual and slow. Therefore, understanding the transient characteristic of permeability evolution in fractured coal is of fundamental importance to CM recovery, and the CBM instruction induced complex interaction between stress and sorption chemistry exert strong influence on the transport and sorptive property of the coal, and these include influence on the gas sorptions and flow and core deformation, porosity change and permeability modification. These events and these components are going to influence about the CBM instruction and CBM recovery, and the individual process in the absence of full consideration cost coupling on the basis of very well known disciplines such as elasticity, hydrology and heat transfer responsible to model such. Fundamentally, we can utilize the principle of elasticity and mechanics in analog between the thermal contraction and matrix swelling shrinkage associated with gas adsorptions and desorptions in coal bed, then following the classical mechanics, and the reduction in temperature is actually function of fabric shrinkage minus leading a potential change in the porosity and porous strata. Therefore, we can apply this concept in case of CBM regarding matrix swelling in coal bed and others as analogous. As far as mechanics is concerned, we can say that effective strain is a total strain minus swelling strain minus thermal strain plus compaction strain is responsible for the effective strain, and effective strain is going to control the release of coal bed methane. These leading to the coal deformation and then flow in coal seam and then chemical transport in coal seam and then thermal transport in coal seam and resulting the release of CBM induced changes in strain and which are going to change in permeability and porosity. If we are going to see about the matrix fracture interaction, we can say that phi is equal to phi delta C effective matrix fracture interaction, and this become porosity is equal to porosity effect based on the strain is a basis for the porosity model, and the permeability, intrinsic permeability is a basis for the permeability model. So we can utilize by adopting the local rule includes adsorptions, coal swelling and shrinkage, and coal permeability alteration. These three are the principal factors responsible for CBM release as well as post effect of CBM release. So two models peoples are describing, porosity model and permeability model. The porosity model is purely based on the poroelasticity. However, permeability model, one very famous is the matchstick model. Here the post-swelling aperture and the pre-swelling aperture in case of initial state of this CBM release is almost same. However, when there is a matrix shrinkage, then the post-swelling aperture is different and the pre-swelling aperture is different, and due to here decrease in porosity permeability and here increase in permeability. The changes in cleat parameter permeability is responsible for the changes during extraction and after extraction, and the matchstick geometry model is considered to develop the relationship between porosity and permeability and widely utilized in scientific domain. And another fuel is shale gas. Keeping in view the energy crisis, which is a consequence of rapid development of global economy, has become a critical issue that requires immediate attention toward the shale gas. And the shale gas is the natural gas that trapped within the shale formation, as name indicates, shale gas, in the condition of the adsorptions or ionization. In shale, natural gas exists in form of absorbed gas as 90%, 95% or 98% CBM also absorbed on the coal surface. Similar here, and free gas and dissolved gas, similar way as CBM. Among them, the absorbed gas on the organic material and free gas within the rock pores or natural fracture system are the dominant form. And during the past decades, shale gas development have changed the energy structure in some of the countries of the world, and they have started producing shale gas at commercial level, like USA, like China, in India also, Australia, etc. So we have huge resource of the shale gas in sedimentary basin, almost found in every country, but more in China, India, USA, Australia, Canada, etc. And the last year only 3 countries, America and Canada and China, started producing shale gas at commercial level. So the hydraulic fracturing technology play a very important role in the in situ extraction of shale gas, and other gas also utilized in conventional natural gas reservoir also sometimes, but The hydraulic fracturing is a till date available technology for extraction of shale gas, although it is problematic to utilize huge quantity of water which requires availability as well as disposal of water. Since the gas flow resistance of the shale gas is considerably higher than the conventional gas, therefore stimulation strategy have to be carried out for economic production. Therefore, successful development of this unconventional resource depends highly on the advanced technology and requires some advances in hydraulic fracturing and others, or some other way for fracturing of shale to release the shale gas. Friends, you can see the global distribution of shale gas. You can see the available in India also, in China also, in European countries also, in state in Australia, in Africa, lower tip of Africa, etc. As far as the geological concern, I have taken from some net source, and the net source has taken from this US Energy Information. Conventional non-associated gas and this oil, you have idea, the oil lower side water, then oil, then gas, and conventional way we are going to extract. However, some unconventional is here. We have already discussed coal bed methane, and the overlying shale we can also utilize, which was earlier recognized as waste material or road metals, can be utilized as a source of energy. This cartoon is representing one view regarding the availability of the shale gas and the way in which we are going to extract. You can see here, during the hydraulic fracturing, a mixture of water, chemicals and sand is pumped down to a borehole at higher pressure. Through this sand as well as chemical as well as water pumped down in the targeted zone to create fissures where the water is going to pressurize this zone and the sand is going to make some log type of structure. Suppose one fracture is developed here, then sand grain is going to create a log type of roll which cannot allow for closing of fracture further. In this way, the hydraulic fracturing is going to make the fissures around their targeted site. You can see the water pressure opens up cracks in the rocks and the sand grains log into the space to keep them open, allowing the released gas to flow out of the rocks, rock means shale, and travel back up to the borehole. You can see here the supply of the water, chemical and agents going to create the fractures and log the fracture, open the shale rock, and the gas encased in pore in adsorbed form are present in the fracture cracks in free form or in dissolved form. Subjected to under confinement means residing under the confined stress. Therefore, when get suitable path, then started moving from the higher pressure side toward the lower pressure side. In this way, the formation of features, formation of fractures, crack, fissures, networks is going to facilitate about the release of shale gas, and which can be taken back or through second pipe. The problem associated with extraction of shale gas is two. One is availability of huge water for the hydraulic fracturing is a major problem. Another is the disposal of recovered water from the shale reservoir. Because the nature of recovered water is polluted in nature, require lot of precautions to clean the water for reuse on one side. Another, due to formation of fissures, cracks and others, there is a development of the voids as well as discontinuity. The evolution of discontinuity means fractures, cracks, etc. due to hydraulic fracturing also become a site for burst of mechanical energy which come in form of P and S wave and which is responsible for vibrational effect, sometimes may also cause earthquake of moderate to moderate magnitude. So another side, due to continuous change in permeability, porosity and release of gases, this strata is not suitable to hold the overlying weight of the strata which was earlier. Due to loss of strength of the gas containing shale strata sometimes provide subsidence and sometimes provide instability problem like slide and others in slopy ground. These lectures I have prepared from some research paper, and the major contribution or the major content of this lecture is taken from the paper written by Jishan Li and John Whale Chen and Sir Derek Ellsworth. He is a very renowned person in field of such innovative mechanics applications. And Hongyan Q and Dong Cheng written a paper on interaction of multiple processes during CBM instruction, a critical review published in International Journal of Coal Geology, and number of other papers on shale gas and instruction of shale gas and CBM as support, partial support. As far as conclusion is concerned, friend, you know well, the coal bed methane is one of the fossil fuel associated with coal. Similarly, the shale gas is also one of the unconventional fossil fuels widely utilized through some of the advanced country, and we are hoping for future utilization at commercial level in our country also. The CBM recovery activates a series of coal gas interaction and which can be well explained through the concept of poroelasticity under variable temperature and pressure condition. The coal permeability models are required to define the transient characteristic of permeability evolution in fractured coal during CBM recovery. And this CBM reservoir have dual porosity and permeability. You have already understand. A broad variety of models are required to represent the effect of sorption, swelling and effective stresses on dynamic evolution of the permeability during recovery of the CBM or extraction of CBM. Besides this, the shale gas is also a natural gas that trapped within the shale formation similar to the CBM in condition of the adsorption ionization. In shale natural gas exists in form of the adsorbed gas, pre-gas and dissolved gas, and hydraulic fracturing utilizing a mixture of water, chemicals and sand are used to fracture the shale strata for release of shale gas. Dear friends, in this class we have elaborated about coal bed methane and shale gas and their engineering geological view in brief. Thank you very much for your patience hearing. Thank you.